Hi there, and welcome back to VCE Master Academy. So far, we have explored the unit circle and the exact values. Today we are going to see what sine and cosine look like when we draw them as graphs, and they make two beautiful, smooth waves. Don't worry if this looks hard. We'll make it simple, step by step. Let us start with the sine graph, y equals sine x. Imagine a point traveling around the unit circle, and we track its height as it goes. That height, plotted against the angle, traces a smooth wave. It starts at 0. It rises to its highest point, 1, at pi over 2. It comes back to 0 at pi. It dips down to its lowest point, minus 1, at 3 pi over 2. And it returns to 0 at 2 pi. Then it repeats forever. Two words describe this wave. The first is amplitude. That is, just how tall the wave is, measured from the middle line up to the peak. For y equals sine x, the amplitude is 1. The second is period. That is, how far along you go before the wave repeats itself. For sine, the period is 2 pi. Here is the sine wave, with those key points marked. 0, up to 1, back to 0, down to minus 1, and back to 0. One smooth hill and one smooth valley. That is one full period. Now the cosine graph, y equals cosine x. It is the very same wave shape, but it starts at the top. It begins at 1, drops to 0 at pi over 2, reaches its lowest point, minus 1 at pi, back to 0 at 3 pi over 2, and up to 1 again at 2 pi. So cosine is just sine that got a head start. Same amplitude of 1, same period of 2 pi. Here is the cosine wave. Notice it starts high at 1, while sine started at 0. That is the only real difference in shape. Now, the useful part, how numbers in front change the wave. Look at y equals a times sine of nx. The number a controls the amplitude. It stretches the wave taller. The amplitude is the size of a. We write it as the absolute value of a, so the graph reaches up to a and down to minus a. If a is negative, the wave simply flips upside down, reflected in the x-axis. The number n controls the period. The period becomes 2 pi divided by n. A bigger n squeezes the waves closer together. And the range, all the y values the wave covers, is from minus a to a. The same rules work for cosine.
Example 1. Nice and gentle. For y equals 3 sine x, the amplitude is 3 because that is the number in front. The period is 2 pi because there is no number squeezing the x. N is 1. The range is from minus 3 to 3, and the maximum value is 3, first reached at x equals pi over 2, just like the normal sine wave, but 3 times taller. Example 2. Medium. For y equals 2 cosine of 2x, the amplitude is 2. The period is 2 pi divided by 2, which is pi, so the wave repeats twice as fast. The range is from minus 2 to 2. Now let us find where it crosses the x-axis between 0 and pi. It crosses when cosine of 2x equals 0. Cosine is 0 at pi over 2 and at 3 pi over 2. So 2x equals pi over 2, giving x equals pi over 4. And 2x equals 3 pi over 2, giving x equals 3 pi over 4. So the x-intercepts are pi over 4 and 3 pi over 4. Here is y equals 2 cosine of 2x. See how it rises to 2 and falls to minus 2. That is the amplitude of 2, and it completes a full cycle in a length of pi, with the crossings at pi over 4 and 3 pi over 4. Example 3, an ATAR style one, with a reflection. For y equals minus 3 sine of 2x, the amplitude is the size of minus 3, which is 3. Because the 3 is negative, the whole wave is flipped upside down, reflected in the x-axis. The period is 2 pi over 2, which is pi. The range is from minus 3 to 3. Let us evaluate it at x equals pi over 4. Minus 3 times sine of 2 times pi over 4, that is minus 3 times sine of pi over 2. Which is minus 3 times 1 equals minus 3. So at x equals pi over 4, the flipped wave is at its lowest point, minus 3. Where does this show up in real life?
Think of a buoy bobbing up and down on the ocean. Its height above the average water level can be modelled by a sine wave, like h equals 0.5 sine of t. The amplitude, 0.5, tells you it rises half a metre above and drops half a metre below the average. The period tells you how many seconds one full bob takes. Sound, tides, springs, and daylight hours all follow waves like this. Quick summary. Sine and cosine both draw smooth, repeating waves. Sine starts at 0. Cosine starts at the top, at 1. In y equals a sine nx, or a cosine nx, the amplitude is the size of a, and a negative a flips the wave upside down. The period is 2 pi divided by n, and the range is from minus a to a. Now it is your turn. Pause the video and try these 5. 1. State the amplitude of y equals 5 sine x. 2. State the period of y equals cosine of 4x. 3. State the amplitude, period, and range of y equals 2 sine of 3x. 4. Find the maximum value of y equals 6 cosine x and the first x between 0 and 2 pi where it happens. 5. Find the x-intercepts of y equals sine of 2x between 0 and pi. Ready? Let us check them together. Question 1. The amplitude of 5 sine x is just the number in front, 5. Question 2. The period of cosine of 4x is 2 pi divided by 4, which is pi over 2. Question 3. For 2 sine of 3x, the amplitude is 2, the period is 2 pi over 3, and the range is from minus 2 to 2. Question 4. Cosine has its maximum of 1 at x equals 0, so 6 cosine x has a maximum of 6, first at x equals 0. Question 5. Sine of 2x is 0 when 2x is 0, pi, or 2 pi. So x is 0, pi over 2, or pi. Those are the x-intercepts. Fantastic work! You can now picture sine and cosine as waves and read their amplitude, period, and range at a glance. Remember, you are mastering VCE Maths, one concept at a time. I will see you in the next lesson at VCE Master Academy.